Hi, my name is Irfan bin Abdul Muttalib. Now I will talk about our introduction. For this project, we are using Gauss elimination method to analyze the vehicle flow traffic as seen in figure 1. Figure 1 shows that there is 4 roads that has been labeled as road 1 to road 4 in each intersection. And our objective is to propose the ideal vehicles allowed in each intersection per hour. So that's all from me. Thank you.
Hi, my name is Muhammad Amir Ashman and I will continue the presentation with literature review. The first word for review is traffic flow. What is traffic flow? Traffic flow is the study of connections between vehicles, drivers, and infrastructure, including highways, signage, and traffic control devices. The study is to understand and develop an ideal road network with effective movement of traffic and minimal traffic congestion problems. Traffic congestion is becoming increasingly problematic as a result of urbanization and the widespread usage of roadway vehicles. Flow of traffic is varying from hour to hour in morning and evening. The traffic flow will be high during office hours in general. The second word for review is linear algebra. Algebra has been seen as a crucial step in students' mathematics learning. It has been recognizing linear algebra as a difficult subject for most students. Linear algebra is important. Why? Because it introduces students to thinking, and generally students have conceptual difficulties in a linear algebra course. The final word for review is Gauss-Jordan elimination method. Gauss-Jordan elimination is a method that involves systematically eliminate some variables from equations. This method being extension and widely used. Not only restricted for figures and numbers, but can use in various fields including engineering. It is more reliant on metric analysis and computation. They focus on block priority, iteration strategies, and ways to increase the quality of computed solutions. This is the table for our project. For the fact number 1, to analyze the flow traffic for a road network of a T-junction. The ideas for the fact is to use system of linear equation. The learning issues is the number of vehicles at each road network of a T-junction. And for the action, we read and understand the problem statement to represent it in a system of linear equation. For the fact number 2, find the number of vehicles per hour, VPH, for the T-junction. The idea is used in the Gauss-Jordan elimination method to solve the system of equations. The learning issues for this fact is linear equations for each intersection and the T-junction. In the action, we calculate the number of vehicles per hour using Gauss-Jordan elimination method. For the fact number 3, assume construction work is undergoing at the T-junction. The idea of the fact is the number of vehicles is limited. The learning issue, the value of x, y, and z. And the action, we substitute the limited number of vehicles into the equation of the Gauss-Jordan elimination method was done. That's all from me. Thank you.
My name is currently the mahasiswa yang mengajukan SDF 200 people. So the methodology of the case study that has been selected for solve the problem of traffic flow is by using Gauss elimination method. What is Gauss elimination method? Gauss elimination method is a linear and multilinear algebra, a process for finding the solution of a system of scalarless linear equation by solving one of the equation for one variable and then substituting this expression to the remaining expression. So the full process, so the first step is evaluate x1 of R2, and the second step is inverse the sign of second column, and the step 3 is eliminate x2 of R1, and the step 4 is eliminate x2 of R3. Okay, the last step is eliminate x3 of R4. So that's all for the methodology. So I will pass to my friends to explain about calculation of this case study. So that's all for me. Thank you.
Hi, my name is Gauss Jordan, and now I'll explain the calculation discussion of our engineering problem. So, first step, we provide a figure to better visualize and analyze the flow of traffic for the network of the T-junction variable. The variables represent the flow of the traffic between the 4 intersections in the network. Then we try to write a system of linear equation to better represent the figure. Next, we first use the Gauss-Jordan elimination method to solve the system of equation. We write it in a augmented matrix form and reduce it to row column form. So the step 1, we eliminate x1 from row number 2. And step 2, we inverse the sign for the second column because we want to keep the right hand side positive. Next, for step 3, we eliminate x2 of row 1. And step 4, we eliminate x2 from row 3 instead. And finally, step 5, we eliminate x3 from row number 4. Hence, we obtain a system of equation from this form echelon form, which is x plus w equals to 255, y minus w equals to 175, z plus w equals to 340. We can also express each leading variables in terms of remaining variable. So we get x equals to negative w plus 255, y equals to w plus 175, z equals to negative w plus 340. So if an construction work is undergoing a T-junction and the vehicles are being tilted, for example 100 vehicles per hour, we will obtain new values for x, y, and z as shown. For the discussion, we can assume that the largest value of w without causing negative values for x or z is 255, and the smallest value of w is 85. Any work on road CD should allow traffic volume or at least 85 vehicles per hour. Therefore, to keep the traffic flowing, 240 vehicles per hour should be routed between C and D, and 155 vehicles per hour between A and B, and 275 vehicles per hour between A and B. That's all from me, thank you.
Hi and hello, my name is Muhammad Rosli. Number metric is DF200159. Today I would like to talk about the part last in this project is the conclusion. In the conclusion, a skilled engineer should be conversant with a wide range of problem-solving methodologies, including both traditional and cutting-edge technologies. This is because if technology fails, a smart engineer must be able to use action method to demonstrate that he or she is not unduly reliant on the modern methods that use advanced technology. In this project, linear equation were used to analyze the flow of traffic for a network at T-junction in a Parit Raja. As a result shown, the third equation of this system according to the model, the Z will be minimal when W is big feasible not exceeding 340. As a result, 200 VPH would be rowed between C and D, 155 VPH between A and B, 275 VPH between A and D to keep traffic moving. Overall, all the objectives of this project as stated in the objective are successful.